Rightio, let's have a wee look at some of these excellence questions for those of you that are maybe a little bit stuck on this and haven't done it in class or haven't been able to figure it out. So we've got this one here. It was C, I think it's the 2017 paper with 1C. We've got this equilateral triangle that's been drawn on one side of a square. So, of course, this is not a 3D kind of question. It's just been drawn on one side of a square. So that's kind of good to know. This is just two-dimensional. We also know that it's an equilateral triangle, isn't it? So that means that this is here is 6 centimeters and this here is 6 centimeters. We also know that it is a square. So this guy here and this guy here are also 6 centimeters. What we want to find out, of course, is D, how long that length there is. Yeah? Okay. So is there anything that we could possibly work out? So we think about it, I can see triangles happening here, so we can probably, deal with some triangle stuff. There's probably some angles that we could calculate as well. So let's see, what other information could we find out maybe before we even get started? So let's have a look at the angles. Square, so those must all be 90. Can we work out the angles inside this triangle? We can, eh? That is an equilateral triangle. So because it's an equilateral triangle, all of the angles are the same. So each angle inside the triangle is going to be 60 degrees, okay? 180 divided by 3. Sorry, an email just popped up, so I just had to stop it and start again. So it's this triangle here, isn't it, that we're actually dealing with, and we now know that size of that angle up the top, angle CBA, is going to be the 90 degrees for the corner of the square plus the 60. Okay, so we've got 150 degrees in that corner. All right, well, let's redraw this triangle, eh? We know it's equilateral. We know this is 150 degrees. So, of course, my drawing's not really to scale, is it? These two angles here we'll be able to calculate, won't we, nice and easily? So 180 minus 150 divided by 2, so they're going to be 15 degrees each. And we know that we've got 6 centimeters there and 6 centimeters there. Maybe, hopefully now that's a good enough hint to kind of get you started. From there, you can chop this in half. Okay, any isosceles triangles we can cut in half like that and make it into a right angled triangle. So you can use 75 for that top angle, 15 and your 90. And you're away laughing, okay? And then you'll get this length here, and then you can times that by 2 to get your end one. I'll just move this up here. All right, well, I'll just pause this, and then we'll go to the next question. Okay, let's have a wee look at this one here now. I think it's 2D maybe, or maybe 1D, I can't quite remember. So we've got this coffee shop, and we're told the horizontal distance across a counter in a coffee shop is 2 meters long, okay? So we can put the distance, that horizontal distance in. Okay, we're told it's 2 meters. And then we're also told that all the seats have the same diameter, which is D. Okay, now notice that it's drawn there on one of the seats there. Here's our other seat, and I'm just going to draw this one on an angle like that. And I'm going to draw this one on an angle like that because it's the same thing, isn't it? Diameter, it goes all the way around your circle. And of course, the spaces are also the same diameter. Okay, it's the same size as the seat. They mentioned that, but there. So we can do that, and we can do that. Now I'm drawing them like this because it might help you to notice something about, how long that length overall is of all of the seats. Okay, so what we'll do is let's draw out the triangle that we're going to need to deal with. It's a Pythagoras question, okay? We're wanting to find out the diameter of the seats. Here's our seats. We're told this horizontal distance here of the counter, and we've got A and B, and we want this whole thing in terms of A and B. So we're going to create a triangle. So we've got 2 meters. We've got our D plus D plus D plus D plus D. So we can call this length 5D, can't we? Yeah? And then here's our right angled triangle, and then we've got this length here. So it's this part here, isn't it? How could we describe that? Well, that would be b minus a. See that? Yeah, b minus a, because it's this length minus the a length, so we're left with that bit there. All right, so we've got now, and this is probably all that you need to get going. It is a little bit of algebra. Okay, all these excellence questions, they are hard. Okay, they are, and practice is the way to go. And also looking at those questions with the using algebra for geometric reasoning. That was, I can't remember what section of the book, but it's right near the back. Okay, it's very, very close to the back of the book. Okay, so this guy here, if we now use Pythagoras, yes, we've got some letters and stuff involved. We don't need the m, of course, because that just stands for meters, so let's get rid of him. We can now write this as Pythagoras, can't we? We want D, and we want it in terms of B and A. So it means we want to end up with D equals something that's going to have A and B in it. So if we think about Pythagoras, we get the hypotenuse by doing the 2, that side, squared, plus this other side squared. We'll put that in brackets so that we're being careful. We can write it like that. Now it's a little bit of algebra. So let's just leave this side alone. And of course it's not 5d squared like that. It's actually 5d and the whole thing squared. So just watch for that. That's my bad. So 5d squared is 4 plus b minus a squared. So we can write that as b minus a, which equals 4 plus b squared minus 2ab plus a squared. So 25d squared, so just dealing with that, getting rid of the brackets now, equals 4 plus b squared minus 2ab plus a squared. So d squared equals all of this divided by 25. I'm sure there's actually a much neater way to write this. Oh, that's a squared there, over 25. Oh, that's a squared. And then our final answer will be the square root of all of that. I'm thinking, for neatness sake, it would be better to just leave the b minus a squared in brackets. It would look a lot neater. So I could have written instead, it's simply this line here, this line here. We could have just gone from that to 25d squared equals 4 plus b minus a squared, and then divided that by 25. I just think this will look a lot neater. And then done the square root of all that. Okay, cool. All right. Righto, let's have a wee look at this question now with the wheel. So yeah, question D here about the points ABC lying on the circumference of a circle. So we've got the straight line, PBT, and they're telling us it's a tangent to the circle. It obviously is as well from the picture. And angle CBP, they're calling X. All right. So we need to show that the size of angle ABC, so this guy in the middle here, is 90 minus half X. Okay, so that's what we're wanting to do. So let's do that. Having a wee look at the information that we've got, okay, we've got a couple of bits of info. The fact that that angle there, angle ABC, is going to be the same as angle ACB, isn't it? Because that's an isosceles triangle, so they're going to be the same size. So that's kind of cool to know. Notice that it uses 90 in the answer here that we're aiming for. So that's kind of interesting when you think about it. Well, where would 90 come from? So it could be something to do with angles in a triangle, making 180. If we had a right angle triangle, then you could see how you could end up with 90 coming from that. However, we haven't got a right angle triangle, and we don't know that one of the angles in there is 90 or anything like that. So think, how else might we end up with 90? Well, 90 we've got a tangent going on, you think about what we know about a tangent, and that is that it always forms this perpendicular angle with the radius and the diameter. So let's put in a radius in there, because we know that that means this is 90 and also this is 90. So that's, an interesting piece of information. If you want, you can create a center, and, in the answers they did that, and I think that's quite a nice idea. And they've said let O be the center. Sorry, I'm just going to flip the computer around. So let's do that, okay? Let O be the center. Call it O because that's often what they call it in circle geometry, isn't it? Okay, so if I was the center, then this angle here, angle OBP, is 90 degrees, isn't it? And then you'd put your reason there, okay? Tangent to a circle. All right. So then, if we then talked about, because remember, altogether we want this yellow bit in the middle. So let's see if we can find each section of the yellow bit. Let's see if we can find that little bit and that little bit. So that's why the next step that, again, you'll see in the answers, is going, okay, well, how could I describe angle OBC? So this first guy here. So angle OBC, well, we could describe that as 90 minus x, because we've got our little x degree there on the bottom there. All right, sweet. So can we do the same on the other side? What do we know there that can help us? And again, oh, thank you very much, honey. So what have we got? What do they do in there? Angles and triangle 180. COB is 2x. COB is going to be 2x. Oh. All right. Yeah, this is a goodie. Okay, so I've got it. So yeah, the next thing that we're looking at is, okay, what else can we do? What else can we find out? And notice that if we do another radius, we can do another radius from the center out to C there. It's an isosceles triangle, so again, it's going to cut it in the same place. So then this wee guy in here is also going to be, so angle OCB. Angle OCB is also going to be 90 minus x. Yeah? Okay, so what else can we find out? Well, we could then find out what this guy in here is. And this is why that next step in the answers that you'll see talks about angle COB. Angle COB, because we've got our 180 in this little triangle that we've made now, we can do 180 minus 90 minus x minus 90 minus x. Okay, so that's 180 minus 90 plus x minus 90 plus x. 180 minus 90 is 0, so that gets rid of that. And we've got x plus x makes 2x. Yeah, and so that is angles in a triangle adding to 180. Cool, okay, so that's pretty cool, because now, can we use that on the other side? Let me have a look. We need to find, oh wow, yeah, cool. So that means we've created an arrowhead here, haven't we? So that means A must be x. Yeah. And I think, yeah, that's what they do in that too. So yeah, angle CAB will be x, and that's because angle at a center is 2 times the angle at the circumference. So this guy here is x. And we're going places. So overall, in our huge big triangle, the whole A triangle ABC, so that guy there, we're now at the point where we've got those 2 bottom angles. So of course we're wanting to find one of those bottom angles. We can find them by doing 180 minus x divided by 2, yeah, to get those actual angles. So 180 over 2 is 90, x over 2, x over 2. Oh my gosh, and that's it. Ha ha! Yeah, that's it. So there we go. We've just proven it.